Hello students, a little bit late due to some technical issues.
Video.
So is everything clear now? Video and audio now? Is it clear for everyone? Shall we move on the class? Yes, good afternoon Ruksar Bano, good afternoon Hema Prakash, good evening Rahul, good evening Banu Prakash, good evening Rudrajay Singh. Thanks for waiting. Thanks for waiting everyone. So without delay I will move on to class. This is part 6 we are going to have. 5 parts we have completed. I think everyone know it. This is part 6 of engineering hydrology AE or AEE. Part 6 of engineering hydrology AE or AEE. So the previous part, yesterday we discussed a few numerical formula. So about that we'll solve the questions. This is the question. This is the previous UPPSC, APPSC, MPSC, TSPSC question. 4 states, this model and this model, same, very important. 4 states, this model of questions provided. So very important model. The area between the ISO heights, 450 mm and 550 mm is 100 square kilometer. Means this is P1 450, this is P2 550 and A1 is 100 square kilometer, and between 550 and 650 means we'll take 650 as P3, 150 square kilometer as A2. The average depth of annual precipitation over the above basin will be. So P average is required. Very good Banu Prakash. You are too fast like Robo. I think Robo also less than you. You are too fast Banu. Very good. So P1 plus P2 by 2. We have given the formula already, you remember. So I am not writing formula here. P1 plus P2 by 2 average precipitation, 450 plus 550 by 2 into 100 plus 550 plus 650 by 2 into 150 divided by total area. Divided by total area is 250. P1 plus P2 by 2 into A1 plus P2 plus P3 by 2 into A2 divided by 250. So it is the answer 560 mm. 560 mm. Answer is option C. Option C. Next question. The area between the two ISO heights. Same. Clear. See here. This is in millimeter. This is in centimeter. Small change. Instead of 550, they have taken 55. Instead of 650, they have taken 65. Same area. 100 kilometer square. 150 kilometer square. Same area. What is the change? What is the change? Only units have been changed. So answer is same. Instead of 560 mm, instead of 560 mm will take 56 centimeter. That is only the thing. No variation in the previous question and this one. Units instead of millimeter they have taken centimeter. We'll move on. See, same values. Clear? Only small changes. Same values, only small changes. Given in meters. Given now in meters. 0.45, 0.55, 100 square kilometer, 0.55, 0.65, don't take here 65 only, 0.65 meter, 150 square kilometer. I told you that different states have taken same exam, same question. One state is giving mm, one state is given centimeter, another state is given meter. 3 states, 3 different units. So this is the model. Rahul, you remember, this is the model. UPPSC. Ajay Singh, this is the model. Previous UPPSC given. So answer is 0.56. Just units only different. Hema Prakash, correct. Just units only different. So this is previous UPPSC model. Okay. Done. We'll move ahead. So these are the questions given with respect to mean precipitation determination. Now today we are going ahead. Flood frequency analysis or the same topic considered as frequency of point rainfall. Flood frequency analysis flood frequency analysis or frequency of point rainfall. So, rainfall and flood. So, rainfall and flood. Is it with both the words, both the activities? Is it uniform? Is it controllable by human being? Will the activities of rainfall and flood? Will both activities are uniform and controllable? Shall we control occurrence of a flood or occurrence of a rainfall? Shall we control? Shall we limit amount of water delivered by rainfall, amount of water delivered by flood? So in nature, the most non-uniform and very importantly, unpredictable events. The most non-uniform and unpredictable events. These are only the most non-uniform and unpredictable events. These are only rainfall and flood. These are only the most non-uniform and unpredictable units. Events. So what is a flood? Which incident, which event will consider as a flood? The excess rainfall which overflow the hydraulic structures, catchment areas, canals, Excess rainfall which overflow. Yes, correct, Rudrajay Singh. Very good, Prakash. Excess rainfall which overflow the hydraulic structures and cause, very important. Okay, it can overflow, nothing it has been caused, no issue for us, no? But it cause damage to life and properties. The excess rainfall which cause damage to life and properties. Yes, it overflow. For example, you have constructed a canal. You have constructed a canal. This is the canal you constructed. This is MFL, maximum flood level in the canal. Even 30 years highest flood occurred in the canal. You understand the point? Maximum flood level. Even the 30-year highest flood happened in the canal. Highest depth of flow is this one. But still, today suddenly one heavy rainfall, which is above maximum flood level, rises up, then overflow on the bank on the both sides. That overflown water is controllable, restricted, no problem. Uncontrollable and non-restricted. And it is a huge for long duration, 1 day, 2 days, 3 days. Then it causes damage to human life, animal life, plant life. Dhruv, it will be helpful for GPSC also. Any PSC, you can study hydrology. Subject is not varying. Dhruv, Mr. Dhruv, subject is not varying. You can study this hydrology for any kind of PSC. UPPSC, GPSC, APPSC, TSPSC, MPSC, whatever PSC. State government AE, AEE exam. This course of hydrology is sufficient. Dhruv, you understand, Dhruv? Rudrajay Singh, the same syllabus of UPPSC in all state government exams in India. The standard and depth of subject also same. But why we have named UPPSC? UPPSC exam is coming soon. So we have named UPPSC. The same depth of exam we can go ahead for any government competitive exams, AE or AEE exam. Okay, got it? So flood is a heavy rainfall or excess rainfall which causes overflow of water on the banks and finally cause damage to any life. It may be plant, animal, human, any kind of life, and cause damage to physical properties of human. That is called flood. Okay. Then what we can do with this non-uniform unpredictable event of flood? Because by various probabilistic and statistical methods, we need to analyze present, past, previous, very long, previous 30 years before also. Such kind of flood data we are analyzing through probabilistic and statistical methods. And finally what we are doing? Predicting future flood data. So I am writing clearly for you for easy understanding. Okay. Yes, correct, Dhruv. This is full course of hydrology for any PSC. It may be GPSC, it may be MPSC, whatever it may be. So in flood frequency analysis, what we are doing? Prediction of future flood data. Prediction of future flood data. What you are predicting regarding future flood? What you are predicting regarding future flood? What in this data you are predicting? Predicting time of future occurrence. Future occurrence. number of times, how many number of times the future occurrence, number of times of occurrence, percentage chance of occurrence, percentage chance of occurrence. Good evening, Robo 10.0. A new Robo has joined here. So today, for example, I am saying today there is a heavy rainfall happened in Delhi with a flood discharge value of 50 meter cube per second. Happened a huge damage to human life and plant life, animal life and buildings, properties. Now we want to know the same 50 meter cube per second or greater than 50 meter cube per second of flood after how many number of days or number of years, that is the time of occurrence. So you have estimated that the 50 meter cube per second, you have given a 50 meter cube per second, write down. So flood of 50 meter cube per second or more or greater. You have estimated it will be returned after 5 years. After next 5 years. So it is going to be expected only after 5 years. Then what is the possibility? What percentage of chance? Is it 100%? Can you say 100% now 2020? Again same rain occurs in 2025 with 50 meter cube per second or greater. Can you say 100% chance? It may be 50% chance, 40% chance, 30% chance. So probability of occurrence, you understand? It may be a 50% chance, 30% chance, 40% chance. It varies. That determination, percentage of occurrence. Can you guess exactly only one time occurs in 2025? Or between 2020 to 2025, 0 times of occurrence, can you guess it? It may be 1 time, 0 time, 10 time, 20 times, we don't know. That number of times of occurrence, that determination of flood data, exactly after how many number of years it will be written, how many times it will be written, what chance of occurrence, prediction of future flood data. From where we are predicting? Using previous 30-year hydrological data. Using previous 30-year hydrological data. 30-year previous hydrological data. This is called frequency of point rainfall. Flood frequency analysis. Frequency of point rainfall. Frequency of point rainfall. Frequency of flood. What is a point rainfall? Tell me. What is a point rainfall? My dear students, tell me what is point rainfall. Point rainfall, a single rainfall. So we are analyzing one single flood. Point rainfall occurred for one time at one location. Single rainfall or single flood. Is it clear, guys? Point is one point, one location, one time. Clear? One point, one location, one time, one rainfall. Analysis of a single rainfall occurred at one location at one time. That is analyzed through frequency of point rainfall or frequency of flood. Single flood. Yes, correct. Manu, not only, Mr. Banu, not only magnitude, single magnitude, single location. Today it is happened in Delhi. I mentioned Delhi. Rainfall occurred in Delhi. Can you expect in Hyderabad and Bombay? 50 meter cube per second rainfall occurred today in Delhi. So are you analyzing using Delhi's data? Are you analyzing Hyderabad, Bombay data? No. Hudhud cyclone happened in 2015 in Vizag. By taking 2015 Hudhud cyclone Vizag data, can you analyze Titli cyclone in Orissa? It is not possible. So what at one location only we are analyzing. We are analyzing only at one location, not 2 location, 3 location. Exactly today, rainfall happened at one location. That rainfall, that position, that region, we are analyzing. That is called frequency of point rainfall. So first one, the first parameter, the first parameter we are considering return period, same also called recurrence interval of occurrence. Recurrence interval of occurrence. What is this return period? I told you already one example, best example. In 2015 Vizag cyclone, Hudhud cyclone. So after 2015, after how many number of years, same flood or greater than same flood is going to be returned back again into Vizag city. You got the point? 2015 year Hudhud cyclone happened with some discharge value or some depth value, with some magnitude. The rainfall or flood with the same magnitude will be written after how many number of years? Where? In Vizag only. Not in Delhi, not in Bombay, not in Hyderabad. In Vizag only. So, a rainfall of return period we are writing. A rainfall of yes. Specific magnitude, time interval during which storm likely to equal or exceeded. Very good. What is your doubt, Robo? I have not seen. Nothing is there, your doubt. Good evening, sir and sir. Only you have typed that one, Robo. No doubt. Rainfall of specific magnitude or greater than specific magnitude. Greater than specific magnitude. Rainfall of specific magnitude or greater than specific magnitude means, for example, rainfall of 10 centimeter depth or more than 10 centimeter depth. Then, when again it is going to happen, when again it is going to happen in same region, in same region. So time interval in simple return period is a time interval between Robo, you post again, it is not appearing here. How many years after we can estimate now? Banu Prakash, we have the procedure of return period. How many years we can analyze through return period procedure? We can't say exactly. It is varying from rain to rain. Banu Prakash, it is varying from rain to rain. time interval between present rainfall of specific magnitude, present rainfall of specific magnitude or more to its future occurrence. To its future occurrence. That is called return period. The time interval. The time interval. Clear? Time interval between today a rainfall of 10 centimeter occurred. After how many days? 10 centimeter or more than 10 centimeter will be repeated again. That is called return period. Then for this return period, we have a procedure. Procedure for T. T is return period. You write down here. Return period is represented by the letter T. Return period is represented by the letter T. So procedure for T, return period, determination. Procedure for T determination, return period, determination. So procedure for return period determination, take previous flood data. Take previous flood data of the same location. For what location you are expecting a rainfall? From the same location you take previous flood data. Say I will give you with some examples. For example, there is a 40 meter cube per second discharge, 32 meter cube per second discharge, 25 meter cube per second discharge, 45 meter cube per second discharge, and 38 meter cube per second. These are the 5 discharge values. Okay, these are the 5 discharge values. Now, I need a return period. Out of the 5 values, I need a return period for 32 meter cube per second rainfall. I need a return period for 32 meter cube per second rainfall. So, we require 32 meter cube per second rainfall data information, and we have arranged previous flood data. We have taken previous 30-year highest flood data, 40, 32, 25, 45, 38. Now, what we'll do? Arrange given data. Arrange given data in which order? In which order we are arranging? Descending order, highest to lowest. So my comments are disabled. Some technical issue, I think so. My comments are not coming here. Just I am teaching. If you have any doubts later on, you WhatsApp me, my dear students. My comments are disabled, I think so. What is going on? Today, all technical issues are going on. So my comments are not coming. So just I am going to continue the session. So you understand, whatever any questions are there, later on after the session, you WhatsApp me, I will clear all your doubts. So arrange the given data in descending order. Descending order we can write highest to lowest. Descending order means highest to lowest. So we'll arrange first highest value 45, then followed by 45 followed by 40, 40 followed by 38, 38 followed by 32, 32 followed by 25. So we have arranged in the descending order. After arranging descending order, next step I am writing give rank, assign rank. Here I am writing because in that box I will assign rank. Assign rank. Is there any difficulty in assigning rank? Because already we have arranged highest to lowest. Highest is first rank, lowest is last rank. Is it? So that rank is denoted by the letter M. Rank is denoted by the letter M. So ranks are 1, 2, 3, 4, 5. Why we are writing same numbers continuously 1, 2, 3, 4, 5? Because already we have arranged in descending order. If we have not arranged in descending order, we can check. Already we have arranged in descending order. Just give the values 1, 2, 3, 4, 5, highest to lowest. Now what is the rank of our specific rainfall? Our specific rainfall is 32. So the rank of our specific rainfall, M value is 4. Then how many number of variables are there total? Number of variables total. Total number of variables n will consider n is equal to 5. Total number of variables will consider n is equal to 5. So m is equal to 4, n is equal to 5. Now using empirical equation, I will tell you. We have three empirical formula. Using empirical equation, empirical formula to determine T. We are having empirical formulas to determine T value. So first formula we are going to consider. First formula, most famous and regularly coming in our exam, Weibel's formula. First empirical formula, Weibel's formula to determine T. So what is Weibel formula to determine T? T is equal to n plus 1 by m. T is equal to n plus 1 by m. Then second one. What is second one? Hazen's formula. Second one. First Weibel's formula, T is equal to n plus 1 by m. Second formula, Hazen's formula. What is Hazen's? T is equal to n by m minus 0.5. n by m minus 0.5. Hazen formula. Hazen equation. Then last one, California's equation. California's formula. Simple. This is very simple. California formula used in US. Just will take T is equal to n by m. Just will consider T is equal to m by m. Weibel's formula n plus 1 by m. Hazen's formula n by m minus 0.5. California's formula n by m. Return period. So already we have given one example. Now I will write down about it. In the previous slide, m is 4, n is 5. We will write down here. M is equal to 4, n is equal to 5. Using all the three formula, we will get the values. So using first formula, T is equal to 5 plus 1 by 4. 5 plus 1 by 4. 6 by 4. Clear? 1.5 years. According to Weibel's formula, 5 plus 1, n is 5, m is 4. 5 plus 1 by 4, that is equal to 1.5 years. Then second one, according to Hazen's formula, n is 5, m is 4 minus 0.5. So 5 by 3.5. 5 by 3.5. 5 by 3.5 years. Then third one, according to California formula, 5 by 4. 5 by 4 na n by m. n is 5, m is 4. 5 by 4. 1.25 years. 1.25 years. So whatever the value will take highest to lowest after arranging ascending order, give the ranks. After giving the rank, select rank of your magnitude. Understand? First we are collecting previous flood data from hydrological department. After taking previous flood data, arranging highest to lowest descending order. Assign the rank. Then select rank for your specific magnitude. After that, use the empirical formula, Hazen's California formula. So you will get the values of return period between one range. So we'll take here 1.25 to 1.5 years. 1.25 to 1.5 years we'll consider. So we'll go ahead. That is P. Okay, done. Second parameter. So we have estimated 32 meter cube per second is going to be occurred in 1.5 years. Will 100% is it possible to occur in 1.5 years? Is it sure? Can you give guarantee? Will the rainfall is going to be occurred 100% in 1.5 years? Can you give guarantee? Is it sure? No, we can't say. No? Because of that reason, we need to know probability of occurrence. Probability of occurrence. Recurrence, occurrence. Recurrence, occurrence. So you have expected a rainfall. Here you have expected a rainfall going to occur in 1.5 years. Will it be occurred in 1.5 years in 10%, 20%, 50%, 100%? That determination. Probability of occurrence, recurrence, occurrence. The percentage of or fraction of occurrence of rainfall. The percentage or fraction of occurrence of rainfall of a specific magnitude or more. Of specific magnitude or more in T years within its return period. In T years means, this is the meaning of in T years. In T years means within its return period is called probability of occurrence. Is called probability of occurrence. P. Probability of occurrence P. So simple. P is equal to 1 by T. Reciprocal of return period. Probability of occurrence P is equal to 1 by T. Reciprocal of return period P is equal to 1 by T. So now you are expressing in fraction or percentage? You are expressing in fraction. So P in fraction. What we call P in fraction? That word in your exam very important is, if they have given the word exceedance probability, means you need to express in fraction. If the word is used exceedance probability, clear? The word is used exceedance probability. You can express P in terms of fraction. P is equal to 1 by T into 100. What is the meaning of this? P expressed in percentage. P, we write down clearly. P expressed in percentage. What we call P expressed in percentage? What we call P expressed in percentage? Chance percentage. Chance percentage. If the question is about chance percentage, clear? If the question is about chance percentage, you take P in percentage. Question is about exceedance probability, you take P in fraction. Question is clearly mentioned exceedance, take P directly 1 by T. Chance percentage, probability percentage, take 1 by T into 100. Probability of not occurrence. Probability of not occurrence. A rainfall of 10 centimeters of written period 10 years has a probability of 80% of occurrence. Then what is the probability of not occurrence? You understand? Rainfall of 10 centimeter, rainfall depth of 10 centimeter, written period of 10 years. So if you take probability P, what is P? P is equal to 1 by 10. 1 by 10, 0.1, 10%. So it is having a possibility of 10% of occurrence. Then what is probability of not occurrence? It is carrying a possibility of occurrence of 10. Not occurrence Q. 100 minus 10. 100 minus 10 will take 90%. 90% of chances of not occurrence Q. The possibility of not occurrence Q is equal to the probability of not occurrence Q is equal to 1 minus P. So we can write down 1 minus P as 1 minus 1 by T. 1 minus P is equal to 1 minus 1 by T. Same. Q in percentage. Q is asked probability of not occurrence in percentage. 1 minus P into 100. 1 minus 1 by T into 100. 1 minus P into 100. 1 minus 1 by T into 100. Just multiply with 100, you are going to express in percentage. Clear? Then fourth one. So first we have estimated for a specific rainfall written period, how many number of years it is written. Then what is the possibility of occurrence percentage? What is the possibility of not occurrence percentage? Now, it is sure it is going to be happen in some number of years. So in that some number of years, how many times it will occur? Probability of occurrence of R times probability of occurrence of R times in n years. Probability of occurrence of R times in n years. I will explain you easily. For example, there is a rainfall with a written period of 2 years. A rainfall with a written period of 2 years. Okay. if you take a span of 10 years, how many times it will occur in 10 years? According to calculation, 10 by 2, 5 times, na? Is it not? A rainfall with a return period of 2 years within 10 years, how many times it will occur? It will occur R is equal to, there is a possibility of 5 times 10 by 2. Then, what is the probability? What is its probability? Means, the rainfall with a return period of 2 years can occur 5 times in 10 years. What probability? What percentage of occurrence? A rainfall can occur in 10 years 5 times with what probability? P Rn. We can write down PRN. You understand it? A rainfall of return period of 2 years within a duration, total duration of 10 years, there may be chances of 5 times. What percentage of chance? That is called probability of occurrence R times in n years. Probability of occurrence R times in n years. P of P Rn is equal to. So we'll use factorial formula. N factorial by n minus R factorial into R factorial P power R Q power n minus R. So this is a statistical formula to determine PRN. N factorial by n minus R factorial by R into R factorial. P power R into Q power n minus R. So this is factorial formula to determine. So for this information, T is equal to 2 years. Na? What is P? 1 by 2, 0.5. Q also 0.5. Q also 0.5. 50% chances now. Now we'll substitute here. The probability of occurrence of that rainfall 5 times in 10 years. The probability of occurrence of that rainfall 5 times in 10 years. So 10 years, 10 factorial divided by 10 minus R is 5, 10 minus R factorial, 5 factorial, then 5 factorial, 0.5 to the power R, 5, again Q also 0.5, 0.5 to the power 10 minus 5. So this model of question don't expect in UPPSC, APPSC, any PSC examination. Most complicated Calc is required. Even though Calc is required, it is considered to be a high-end model. This is not at all provided. But you remember the formula. Regarding theoretical formulas, anything will come now. So you remember the formula. Then, so number 5. Probability of not occurrence at all. Probability of not occurrence at all. It is not at all occurring. You have expected a rainfall to be occurring. Here you have expected a rainfall to be occurring 1 time, 2 time, 10 time, 5 times within 10 years. But never it is happening. What possibility? P naught. Never it is going to happen. What possibility? P naught. P naught is equal to Q power n. What is Q? 1 minus 1 by T. Q is 1 minus 1 by T whole power n. That is the probability of not occurrence at all. P naught Q power n. Probability of occurrence at least once. Probability of occurrence at least once. The same will consider hydrologic risk percentage for a hydraulic structure. Hydrologic risk, if it is expressed in percentage for a structure. For example, you are constructing a dam or a barrage. You are constructing one hydraulic structure with a design period of 30 years. One hydraulic structure, whatever it may be, one construction, 30 years design period. In that location, there is a 100-year flood. So no problem, 100 year. After 30 years only 100 years will come, no problem. But by chance, this 100-year flood, if it comes at least one time within 30 years, completely collapsing the structure, the total structure will be collapsed. Whatever budget you have incurred on the project will be getting waste. So before constructing any hydraulic structure, water related structure, you can know hydrological risk percentage of that location. So if it is probability of occurrence at least once, we'll write down as P1. P1 is equal to 1 minus Q power N. P1 is equal to 1 minus Q power N. How can we write down? 1 minus Q. Q is 1 minus 1 by T whole power N. 1 minus 1 by T whole power N. If it is R, R is risk in terms of percentage. R is risk in terms of percentage. 1 minus Q power N into 100. Percentage na 100. So we'll take like 1 minus 1 by T, 1 minus 1 by T whole power N, obtained value multiplied with percent. That is risk. Hydrological risk or failure percentage. If you need safety percentage, 100 minus R, safety you require, 100 minus R, risk, directly will take the formula. Okay. If you need safety, obtained value of R subtracted from 100, that is safety. Risk, 1 minus Q power N into 100, that is risk percentage. Okay. So I'm going to close the session. I'm very sorry for today's inconvenience. Session started late and also some technical errors. Comment box is not coming. Okay, no problem. Again we'll start tomorrow. Okay, numerical questions will solve. If required, I will repeat some of the points, some of the important formula to you again tomorrow. So tomorrow we'll solve numerical questions and then we'll move ahead towards evaporation. Tomorrow class at 4 p.m. same time. I will check all the technical errors. I will discuss with the team and resolve the technical errors. Tomorrow no issues, I think. Okay. So tomorrow same hydrology for AE, AEE. We'll solve numerical questions on flood frequency and also followed by evaporation class. We'll meet tomorrow. Thank you one and all. Bye bye.